students, in the previous class we saw the what is mean by tacheometry, right? So tacheometry is the branch of surveying where we are going to take angles only and we are going to find out distance, horizontal distance as well as the vertical heights, right? So now the instrument whatever used in the tacheometry is called tachometer. So it is a what is called a theodolite, special type of theodolite, but it is fitted with the a special type of cross hairs called right stadia, okay, stadia hairs, right? Stadia hairs you are going to there on the inside of the what is called over the cross hairs, right? So that type of instrument, that type of theodolite, then call it as tacheometer. That type of instrument is called tacheometer. So in front of that we are going to use the leveling staff or stadia rod or something, some type of instrument to take down the readings, right? So this is the introduction regarding the tacheometry and what are the different instruments and what we are going to do with this tacheometry. All those things we discussed in the last class, right? So now the very important topic is principle of stadia method, right? So there are so many methods, right? Stadia and non-stadia methods, okay? In the stadia method we have two methods. One is standard, right? Standard stadia method, that is fixed one, and second one we are having the movable hair method, right? Fixed hair method, movable hair method. In the case of non-stadia, that means you don't have the stadia diaphragm, right? If this is the cross hairs above and below we have a stadia hairs, okay? If that is not there, that is called non-stadia methods, where we saw the one important method called tangential method, right? So now we are going to see the principle of stadia method, that is the fixed stadias are there, no? So what is the behind, what is the principle behind that method, okay? How it will work, how we are going to find out both horizontal length as well as the vertical length we are going to see now, right? So a tachometer is temporarily adjusted on the station P with horizontal line of sight, okay? So now we are going to, okay, take the instrument, right? So it is going to place over the point P, right? So with the horizontal line of sight. Next, let A and B the lower and upper stadia rays of the instrument and the actual vertical separation will be designated as I, right? So here we can see this is A, this is B, okay? This is the distance between stadia heights, right? If this is the cross hair, this is the cross hair, and this is the A, the lower stadia hair, this is the upper stadia hair, A, B, right? A and B. So whatever distance it is there in between, the distance between it is called I, right? So that is represented here, okay? This is A and this is B, okay? Now next what he told now? Let F be the focal length of the objective lens of the tachometer and C is the horizontal distance between the optical center of the objective lens and the vertical axis of the instrument, okay? So let us see here the first thing, what is called F, right? Focal length, okay? From here to here, the distance whatever it is, wherever these light rays or wherever it is converging, no? So that distance is F, okay? So now from this objective lens, the center of the instrument, whatever the distance is there, that is called C, okay? That's what he told there, right? Next, let the objective lens is focused to a staff held vertically at Q, right? So here you can see the staff is vertically held at the point Q, right? Next, say a horizontal distance D from the instrument station, right? So it is there from D distance from the instrument to the staff, right? So now the distance from the center of this thing to staff is small d, okay? So if you are seeing from your instrument, so the upper and lower cross stadia rays is going to intersect the staff at a point A and B, intersect at a point A and B. So now the distance between A and B on the staff is going to called staff intercept. That ray is going to represent with a symbol of small s, right? So with the letter of small s, right? Now, by the laws of optics, the images of reading set A and B of the staff will appear along with the stadia aids A and B, right? So ఇలా A and B మనకి ఏదైతే ఉన్నాయో అప్పు బాటము, రైట్? సో ఇలా ఉంటుంది కదా. సో బోత్ స్టేడియా aids. సో ఇది స్టాఫ్ నుంచి దూరంగా చూస్తే స్టాఫ్ మీద ఎక్కడో ఒక 2 పాయింట్స్ కి, రైట్, ఇలా ఇంటర్సెక్ట్ అయి ఉంటుంది. This is called B and this is called A. Okay, so respectively, like the staff interval, that means the difference between the readings A and B is designated as S. Okay, so that is called staff intercept. Also we can call it as staff interval, right? Similar triangles between the objective and image will form with the vertex at the focus of the objective lens, right? So you can see here similar triangles formed, right? These two are similar triangles, right, at a distance of f. Okay, so next, let the horizontal distance of the staff from f will be the d, then from the similar to d, that is abf and abf, right? So here we can see if this is the f, okay, a B, right? So A, what we saw? A, B, F, right? So now you can see here A, B, F. Okay? So one thing, next what you have? So another thing is we have A dash, B dash, F, right? So A dash, B dash, F. Okay? This is A dash, B dash, F. Okay? These two are similar triangles. Now from these two triangles, what you are going to do now? So AB by D, that means, okay, the angles are like this, right? Triangles are like this. This is A dash, this is B dash, this is B, this is A, right? Sorry, let me see. So upper is A, lower is B, right? Opposite, okay? So this is the one triangle A, B, and here we have A dash, and this is called B dash. This is F. The distance, whatever it is there, small d, right? So next, whatever distance is there from here to F, it is small f, right? So this is small f. So this side divided by distance, that is AB by D is equals to A dash B dash divided by F. Okay? So this is the thing. Now we can form this equation into D is equals to, right, so AB by A dash B dash into F. Okay, so now we know what is AB from the picture. AB is equals to staff intercept, that is small s, right? So now this s divided by A dash B dash is equal to, already we told that from this picture A dash B dash equals to staff intercept, what is called I, right? So that's why we are, if you are going to substitute this equation, right, so you are going to get D is equals to S by I into F. So finally distance D is equals to F by I into S, right? Now A dash B dash is equals to, this value is equal to I, then F by I is a constant or particular instrument is known as stadia interval factor, right? So F by I is called stadia interval factor. Stadia interval factor. Also, it is also known as the instrument constant. So it is denoted by K, and D is equals to F by I into S now. So we are going to substitute with the K. That's why D is equals to K into S. D is equals to K into S. Next, the horizontal distance between the center of the instrument and the station point. Okay, so if you see this figure, right, so from here to here, what is the total distance from instrument to the staff? That is total distance is D, right? From here, what you see, C plus F plus small d, right? So capital D is equals to small c plus small f plus small d, right? So now we are going to substitute all the values here. Okay, so now you got total held distance d is equals to d plus f plus c. Such way c is a substitute for f plus c, right? So this become as f plus c. Then the horizontal distance d from the center total will be equals to d is equals to ks plus c. Okay, ks plus c. So finally we are going to get, okay, instead of f plus c we are going to substitute with the capital C. So remaining d is equals to how much? D is equals to ks. So normally what will be there here? D is equals to c plus f plus small d, right? Small d is equals to how much? C plus f is going to written as c, and small d is given as k into s. So finally d is equals to ks plus c. Okay, this is the final equation for distance, right? So now the distance c is called stadia constant. The distance c is called stadia constant, that is f plus small d, right? F plus c is called stadia constant, and this equation is also known as the stadia equation for the line of sight perpendicular to the staff intercept. Line of sight, right? So line of sight is perfectly perpendicular to the staff, right? So here 90 degrees there now. So straight line, okay? This is 90 degrees, okay? So if it is, this is the condition, okay? So to find out the horizontal distance, we have capital D into, right, ks plus c, okay? This is the equation for the distance determination, okay? If you are not calculating any value, but you are not calculating what is called measuring, right? You are not measuring any distances, but you are going to know the horizontal as well as the vertical distances, okay? Now that is the principle behind the, right? So that is the principle behind the what is called stadia method. Now we can see the stadia method of tacheometry, how we are going to find out both distance as well as the vertical heights, right? So we will see now, right? So now here we are going to take a arrangement like this, right? So now here the objective class is at O, right? So then from here you are going to have the staff intercept of C, A, B is there, right? So you have focal length F and total distance D, okay? Staff intercept from A to B, it is S, right? So we'll see one by one what are the terms is there. Let O be the optical center of the object glass, right? So next, A, B, C are the bottom, top and central heads of the diagram, okay? If you are taking like this, like cross heads na, so that is bottom is A and top is B and central is C, right? So A, B, C. This is the total diaphragm of the what is called diaphragm, right? So this is not diagram, this is at the diaphragm, right? So now O be the optical center of the objective glass. Then capital A, B, C are the points on the staff. Okay, this is on the diaphragm. If you are taking staff now, on the staff what you are having, so those are the values A, B, C and, okay. Now the distance between A and B is equals to I. We know that, right? So that's why A, B is equals to I. Okay, the interval between the stadia heights. Then capital A, B is equals to capital S. That is the staff intercept. Okay, the differences between stadia height readings. Next, F, the focal length of the object. Okay, so that is F is going to be taken. So this is the distance between center O to the principal focus of the lens. Okay, center to the principal focus. Okay, from here to here, principal focus is F. That's why this F. This is the optical center O. Here, small a, b, and in the middle point is C. The height is called small I, and the staff intercept AB is equals to S, right? So that is the things we discussed till now. Okay. Now U is the horizontal distance from the optical center to the staff, right? So from optical center to the staff, whatever distance is here, this is called U, right? Now V is the horizontal distance from the optical center to the image of the staff, right? U1V being called conjugate focal length of the length. So you can see now. What about V, right? So V is the from here to, okay. So whatever here the length, okay, staff intercept on the length is there now. That length is called small v. This small v and small u are called conjugates lengths, right? Next, conjugate focal lengths. Next, small d is the horizontal distance from the optical center to the vertical axis of the tachometer. Okay. So now we can see here small d, okay, from the optical center to here, okay, that is small d. Next, finally we are having capital D, distance from vertical axis of the instrument to the staff, right? So this is the vertical axis, from here to staff, whatever distance is there, that is the capital D. Now, according to the similar triangles, in the previous we saw now, so from the similar triangles of AOB and AOB, right? So you can see here, right? AOB, this is the one similar triangle, okay? AOB and ABO, these two are the similar triangles, right? So we are going to get values like this, right? We are going to get values like this, right? So from this, what we can say, AB by the distance, right? So AB by distance. Okay, now he didn't took those things. Yes, he took the same thing. Okay. That is S by I by S. Sorry. From here they took S by I is equals to, sorry, S by U is equals to I by V, I by small v, okay. So now this can be written as, I by S, okay. So if you are doing ulta, right, so I by S is equals to V by U, right. So I by S is equals to V by U. Now from here, small v is equals to, right, so IU by S, IU by S. Now also from the properties of a lens, okay, so this is the fundamental principle from the optics, right. So IF is equals to 1 by F is equals to 1 by V plus 1 by U, right. So from here, if you are substituting the V value, okay, so we are going to get 1 by IU by S plus I by U, that is equals to 1 by F, okay, sorry, 1 by U is equals to 1 by F. Now by simplification after this, we are going to get S by IU plus 1 by U plus, 1 by U, that is equals to 1 by F, okay. Now from here, we are going to make separate out the small u, right, so that is equals to S by I plus 1 into F, okay. So now if you are substituting inside F, now S by I into F plus small f, okay. So now instead of S by I, if we are going to substitute the, right, so now here D is equals to U plus D from the picture, right. So now D is equals to, so now we are going to substitute this value in the D equation. So D is equals to, U is equals to S by I into F plus D, okay. So now this S by F by I, okay, into S plus F into D. Now the quantities of F by I and F plus D are called constant of the instrument, their values being supplied by the, okay, manufacturer, okay. Actually we need to get it. So finally D is equals to F by I into S plus F plus D, right. So now the constant F by I is called multiple constant and its value is usually 100, right. So F by I value should be equals to 100. This is called multiple constant, okay. So while the constant F plus D is called as the additive constant, its value is varying from 30 to 60 centimeters in case of external focusing telescope, and it is very small, varying from 10 to 20 centimeters, and is there if only, so we are going to ignore. Maximum times the f plus d value should be taken as 0, and the multiply constant will be taken as 100. Please remember, this is very important concept in the tacheometry, right? So next, to make the value of additive constant 0, I already told that the additive constant will be making equals to 0, right? So an additional convex lens known as the analytical lens, right? We are going to provide the additional convex lens inside the telescope, that is called the analytic lens, is provided, okay, in the telescope between the object glass and eyepiece at a fixed distance from former, right? So by this arrangement, the calculation of work is reduced considerably, right? We are going to substitute, right, the f plus d as a 0 value. So when it is become 0 now, whenever you are going to insert a extra additional convex lens inside the telescope now, so there that lens is called analytical lens. With help of that, the additive constant will becomes to 0, right? So next is distance and elevations formulae for staff vertical, that is inclined side, right? So if your instrument is kept at point P and the staff is kept at a point Q, right? So that is at a higher level compared with the instrument, right? So now we can see here the whatever height of instrument is there, that is small h, okay? So from here with the help of these optical center we have O, right? So we are going to take the angles, right? So you are going to take the angle. So whatever angle you take, that is called theta. So this angle is taken over this staff is at a vertical is there, but your side is inclined one, right? So because of that, you are going to get a values of A, right? Instead of A dash, you got the A. Instead of B, you got B dash. And tilting will be there, right? So now the vertical intercept, whatever it is there, it is called small r from the center, and from actually from height of center, the center of this point is at V, right? Okay. So now you can see P is the instrument station, Q is the staff station, M is the position of the instrument axis. Okay. So we already know P is there. This is staff, instrument station. Q is the staff station, where M is the position of the instrument axis. This is the position of instrument axis. Then O is the optical center of the objective. Here it is there. Next, A, C, B is the points corresponding to the reading on the 3 heights, right? So you can see here 3 heights, A, B, C will be there on the staff. Next, S is equal to, that small s is equals to AB, that is staff intercept. Small I is the stadia interval. We know that theta is the inclination, already we saw, and L is the length of MC measured along the line of sight, right? So if you are, this is the inclined side, actually inclined length, but actually horizontal length is D and this inclined length is L, right? So next, D is the horizontal distance and V is the vertical intercept at Q, and H is the height of instrument, R is the central hair reading, and beta is the angle between the two extreme rays corresponding to the stadia hairs, right? So here, whatever angle is there, this is called beta. Now, from here, we are going to see that, right? So MC will be equals to L. This is the vertical, so inclined side, and this will be equals to K into A dash B dash plus C, right? So now, A B, okay? A dash B dash is equal to how much? Okay? So A dash B dash will be equals to, right? So where it is there? It is here, right? So A dash B dash. A dash B dash, if you are taking here, there is the angle theta, right? So the total thing will be equals to, right, S cos theta, right? A dash B dash is equal to S cos theta. That's why K is equals to K into S cos theta plus C. Now the horizontal distance is given by D into D is equals to L cos theta. Since this is the vertical horizontal distance, this is this thing, right? This is called theta. So from this triangle, if you want to know this value, right? So what you have to do, you need to multiply with the cos theta. So L cos theta. So L value is how much? L value is the Ks cos theta plus C into cos theta. Now if you multiply this, D is equals to Ks cos square theta plus C cos theta. Now this is the formula for distance, and if you are taking V, right, vertical distance, that is L sin theta. So L is equals to again K cos theta plus C. Substituting here, you are going to get finally Ks sin 2 theta divided by 2 plus C sin theta, right? So this is the angle for this when the angle is at a elevation, right? So next class we are going to see when angle at the depression, right? How to calculate the distance and as well as the vertical axis, right? So that's all for now. Thank you.